I'm talking about optimistic updates. So things I've done in the past. He mentioned Circle CI and the front end for Circle, which is a continuous delivery platform. It's built in ClojureScript and Ohm, and here's the link if you want to check it out. I encourage everyone, if you're working on a front end and you have the opportunity, open source it. It makes for a great recruiting pipeline, helps other people in the community learn how to write applications, so everyone benefits. Also was the co-founder at Precursor, which was a collaborative prototyping application. It used a lot of the things that I'll be talking about in this talk. And currently at Facebook, working on a team that was built after Facebook acquired RealA, which is a natural language for developers. Just a quick plug. If you're building bots, we have this wonderful thing called Bot Engine. You can imagine if you're dealing with like natural language, there's lots of complex stuff involved. So WIT handles that for you, gives you a nice, simple, declarative interface for building bots. Okay, so we'll start with a definition. What are optimistic updates? So an optimistic update is when the client predicts the result of a transaction and then applies it before the result comes back from the server. So it's called optimistic because the client has to have a fairly rosy outlook on life if it's going to assume the server returns what it expects. So I can kind of give a quick example. I've made this little demo app. So we're going to write a comment. Hello, ReactiveConf. Submit it. And we're going to hold up the request here. We're not going to submit it yet to the server, but we see that we have the comment already displayed. And I'll just send that guy off and go back to the talk. Okay, so the first thing we need when we're building optimistic updates is we need some way for the client to predict the result that the server is going to return. So it has to implement some version of the server logic. So here's a very simple approach. I pulled this out of some early React documentation, simplified it a bit, but so you can see it gets the comments out of the state, adds the new comment, immediately renders, and then it sends stuff to the server, handles errors, that kind of thing. Okay, so seems like this should work. It's very simple. What could go wrong? So here we have the danger of mixing your optimistic state with your valid state. So I'll just show you in the demo. Where we're going to hit the error is when we get to the error handling. So let's go back. All right, so I'm going to write a comment, an unimportant comment, add that, and then I'm going to express my love for Bratislava, send it off. Okay, so for some odd reason, our server, maybe the load balancers are off. It sent my I love Bratislava request first, and then it succeeds. All right, and now, for some other reason, we don't know why, the server isn't going to be able to put this next comment into the database, so it's going to fail. Oh no! I lost my I love Bratislava comment. I can't, the people of Bratislava aren't going to know that I love them. So what happened here? Before that comment was posted, the only comment in the state was this hello ReactiveConf comment. And then when we reset it back to the state before, it hadn't learned about the I love Bratislava comment, and it just wiped everything out. So we need a solution that doesn't mix the state, that lets you keep track of which pieces are good and which pieces need to re-roll back. Okay, so there's a couple of properties that we're going to want here. We want to be able to combine the optimistic state and the real state at render time. And we also want to keep this as far up the stack as possible. We don't want to have to deal with it like in every single component, combining all the states, or else we're going to end up with bugs. It's a lot of stuff to keep track of. We're also going to want to keep track of each transaction so we can roll back just that specific transaction, right? We saw that in the logs, we had those 2 requests. We rolled back 1 request, and we accidentally rolled back both. So we don't want to do that. And then it's also going to come in very handy for when we want to show the user, this is the piece that hasn't saved yet. You know, we'll be able to track down just that one little piece. Okay, so let's look at how RealA does it. So this is a very nice, simple interface for optimistically updating your state. So you have these mutations. You pass some parameters that goes to the server. The server makes a request and then returns the result of some query. So what we're doing is we're just saying, I bet I can guess the result of that query. In this example, we're liking a comment. So we know that the comments count is going to go up by 1, and we can just return that immediately. So this is really nice. It abstracts a lot of stuff for you. You only have to implement a very simple interface. But it does require a lot of work. You have to do it in every step of the way. So let's try to think of a better way. So we were talking about transaction logs and being able to roll back. This sounds like features from our database. So we'll implement a full database, except we don't have to. Someone else has. So Datascript, it's an immutable in-memory database that lives in the browser. There's a kind of a server-side version called Datomic, same API on the client and the server. And if you were here last year, Nikita, he gave a really great talk describing describing Datascript and what it means, and there's a link there. I'll share the slides later so you can watch it. It's very good. Okay, so there's some features that Datascript has that come in very handy when you're doing optimistic updates. It has most of the things, so we'll be able to see this at a very low level, how all of this works. So the first thing is that the database is an immutable value. So this is great. You're working in React. You like values. You like passing state to components. Here you have one value. You pass it in. It renders. You can't change that value. You don't have to worry about getting an inconsistent state. It has a log of transactions, which we saw you need to roll back just the very specific changes that cause you problems. And one really nice feature is that it takes, when you add new transactions, it takes that transaction, diffs it with the state, and gives you back just the changes that you made. So if we look here, we have a transaction. We're just putting we're drawing, this is a sketching application. We're adding a square. So it gives us 2 fields. Remove isn't interesting now. Add does what you would expect. But when we change the X position, it doesn't have all of the extra fields down here. And we have 2 things. We have a remove and we have an add. So it went from 20 to 100. We can tell that. And if we want to reverse that, we just swap the 2 fields. If we wanted to go back, we could apply that diff to the data and get back to where we were before. I just want to make the point, I'm talking about Datascript because it's like a nice concrete thing that you can go look up later. But this doesn't really have to be Datascript. It's just the ideas with the mutable value, the log of transactions, the disk calculated for you immediately. I mean, they could be implemented by a normal JavaScript thing. Datascript is already kind of like a mutable JS on steroids. So if you're familiar with the mutable JS, you have a lot of the concepts. I mean, it's missing the log and the diffs, but it does have the mutable value, which is very important. Okay, so another big problem. Our goal, if you remember earlier, was to predict what the server is going to return. Right, the client has to predict. But how do you predict an ID? Right, that's going to the database. The database is the only one who can assign IDs. So there are a couple of approaches. So the first is temporary IDs, and this is where you make an ID that only the client knows about. It sends it to the server. The server finds a real ID, returns it back to the client, and then the client updates that ID in its store. But the problem you have is that these IDs, they kind of infect your entire code base. You know, if you have two objects that reference each other, some dependency or relationship, those two IDs, I mean, those places in the code will have to also do this translation. And then, not only does it affect your whole front end, it can be fine if you're thinking about it from the beginning, but it causes a lot of bugs if you're adding it afterwards, after you've already built your app. It also infects the server, though. So I'll show you a scenario where you do end up with some synchronization problems. So in this scenario, a client is creating a new comment. It's got a temporary ID. It goes to the server, creates a new ID, and it sends that back and sends the comment to all the new clients. So in this ordering, the temp ID hasn't got back to the original client yet, so it doesn't know the real ID. The other client edits the comment, sends it down the pipe. The server gets it to the original client before the temp ID gets there, and now it doesn't know what to do with this comment. It has an ID 1, it doesn't know what ID 1 is yet, it's going to find that out a little bit later. So what you end up having to do is just keep track of these temp IDs on the server and send the translation layer down every time. So it gets very complex. So a much better approach is to build client-generated IDs. This is where the client builds a stable ID that gets stored in the database, and that's what you use to look things up. So it's much easier to reason about. You don't have to do any of this temp ID resolution. The only problem is that if you're using a browser below like IE 11, there's no way to generate secure or good random numbers. And so an attacker can guess your ID, send his own update, overwrite your data, and then or make you write on his data, steal your update. But it's all solved if you generate random IDs with this crypto API. Okay, and then the last is concurrent updates. If you have two updates that have dependent transactions, like one update relies on the other, and you send them both off and they both get to the server in parallel, maybe the first one fails, how does the second one know when he needs to update? So you end up with this kind of cascading error. There's other solutions, but I think the best way to solve this is to have a nice queue on the front end, send one request at a time. You batch up the requests to keep things fast. You send them all in one payload. And this allows the client to handle the errors before it sends the next request. Okay, so the main points, we need to keep the optimistic state separate. So that allows us to roll back, prevents the problem where we delete our comment. We need to think carefully about how we create new IDs or new objects and how we assign IDs. And then we need to keep track of dependent transactions. Okay, so what else is this good for? If we have a good abstraction here, and I'll go over some of how these things fit in like the real world in a second. It should have some applications beyond your original goal. So I'll do some demos. So this is Precursor. It's a collaborative prototyping app. Hopefully you'll be able to see what I draw. It's a collaborative prototyping app, and I'll just show you kind of a quick demo so you can see how I can edit these things as they're going. I don't have to wait for the server to come back. So I've written this beautiful feature that disables this. So every time I send an update, it's gonna wait. So I can't edit this until it comes back. And it's very frustrating because I can't really work like this. Every time I want to change something, I have to wait, and it's just impossible to work with. So this is where optimistic updates come in really handy. Of course, they're nice in every application, right? You don't want to watch spinners forever. I'll turn that back off. Okay. We also have instant replay. So I have a document here. So since we have a log of our transactions, and we know the client knows how to apply those transactions, that was part of what it had to do to build these optimistic updates. It had to take a transaction and apply it to its state. We can just run that in reverse, or run that again. So replay equals true. Oops. And there it goes. You can see exactly how I built this. And now you have like a new feature that came out of this thing you weren't even trying to achieve. It also gives you multiplayer. So if we copy that. So if I'm over here, I can take, actually I'll do it on the bottom, and then you can see it on this side. So if I'm sketching over here, the other client can see my work because I'm just taking his transactions and passing them over. And so we can, everyone can collaborate, everyone can see everyone else's state. So it adds this new feature that it wasn't really specific to optimistic updates. It just came out of the fact that we have this transaction log, we know how to apply the transactions, and they're the same transactions on the client and the server. We can do local only edits, so this is where you don't send any data to the server, you just keep it on the client. So I've made this like private document that only one person can edit. So now if I try to scribble on him and vandalize it, I get a notification, it's read-only, you can't mess with it, and I can still see my crap that I scribbled on it, but as soon as I refresh, it'll go away. It's gone forever. So the last couple of things, right, I have these transactions. If you remember from the previous slide, we had these, this diff, it is added and removed. So you can also, let's just do a new one. So we'll scribble a little bit more, and we'll make this guy. So when I undo something, all I'm doing is applying the reverse transaction. I don't have to worry about messing up the state because it's just one level down. But I can just keep doing this undo thing forever. Kind of like if you're familiar with Emacs, the undo. It's an infinite log of all the transactions. Even counts the undo as a transaction, which is why I can undo my undos. What was the last one? Oh, better errors. Right, so if I disable syncing to the server, I implemented this other nice feature. All of my features are breaking the app. So if I draw something, right, because it had that, it's lost its connection to the server in this scenario, but since it has those transactions, it can look up which entities on the page are affected. It can highlight them and say, hey, your edits to these entities weren't saved. Do you want to retry? So then if I turn the sync back on, now I get my entities, they're on the server, I didn't lose any work. And you can see how this could be applied to offline mode. So it's just extending the latency longer and longer. It's a lot harder because as you extend the latency, you end up with potential for a lot more conflicts. Okay. So one last thing. So Precursor, we've open sourced it today, so you can go. Thanks. So you can go to GitHub. I think there's also a blog post on the precursorapp.com/blog. Kind of explains, what we were trying to do with it. So if people want to see kind of how this stuff is built, see it in action, a lot of the things I talked about I didn't know until after I built it. So it's a little hacked together, but the main ideas are there. Okay, I think that's it.
Great, thank you very much. So we have quite some time for questions. Number one, stickers.
Sure.
Let's say yes, okay.
PHP to React ratio? I have no idea. Okay, so RUM compared to Ohm. So Precursor is built in Ohm, and David Nolen is here. He's the author of Ohm, and Ohm Next is very interesting. Circle is upgrading their front end to Ohm Next, so I think that's going to solve a lot of their problems. The problem it solves is you have this data in one format that makes sense to you, it makes sense to your API, but the data, when you render it, you need it in some like tree shape. And it's hard to coerce the data into the shape. If you look at the Circle code base, it does a whole lot of work to get things in the right shape so that it renders efficiently. And I think OhmNext solves a lot of those problems. However, I kind of prefer RUM because it's much easier to write your own code that integrates with it. So if you, I'm a fan of Datascript. I use Datascript in my projects outside of Facebook. And it makes it very easy to integrate Datascript into the app. To write your own custom mixins, it has a very, very good way of composing mixins. I don't know if anyone here has tried mixins. They're being deprecated because they didn't work very well. They don't compose at all. If you have two mixins that have the same, that operate on the same lifecycle method, I think it throws an error. And so now they've gone to using higher order components. So if you look at RUM has an excellent way of dealing with mixins. They're all composable. You take a state, you return an updated state. In your experience, right? So ideally, everything is optimistically updated. You have it at the top level. Anything you put in your database is done. Maybe that's a bad idea, but it enables a lot of stuff when you do that. You don't have to worry about optimistic updates. You don't think about them. It just happens for you automatically. Can you use Datascript on the front end if you use a different database on the back end? Yeah, you should. I mean, it's not as nice. You have to write a bunch of translation. Okay, actually, so I shouldn't say it. You don't get all of the benefits, but yeah, it's very useful. There's a JavaScript library called JSEgg, I think. And it does a lot of what Datascript does. It's kind of inspired by it. By Brandon Bloom, he was one of the people that also worked on the Circle front end. JSEG. So I'd look at that if you're looking for something in JavaScript. I haven't used it myself, but I think Brandon's pretty happy with it, and it looks like it does a lot of the right things. Right, edit conflicts. So a lot of it's going to be application dependent. There are some nice data structures that you can use to solve this. So if you know of CRDTs, it's a data structure where you can apply updates in any order, and as long as it gets all the updates, you end up with the same state at the end. So this is what like Google Docs runs on. So if you have that, you don't have to worry about conflicts. You can't have conflicts. Some of the ideas in here are unnecessary, but you still want to have a separation between your local-only state and your real state, so that you can show the user, this stuff isn't saved. Don't close the browser, that kind of thing. This GraphQL, yeah. So if you're using RealA, it makes it a lot easier. I don't know if there's anything specific in GraphQL that would make it easier, but I mean, RealA has facilities for applying the updates. You won't get conflicts. I can't guarantee that. I'm not sure the internals of RealA that much, but it works fairly well. Okay, what Facebook uses for publish, subscribe? So I guess I can talk about this because the things I know about publish, subscribe, I know from looking at the browser. So it's just basically long polling HTTP requests on the browser side, from what I've seen. That I can, I'm not sure what I'm allowed to talk about and what I'm not. The next one. So when is it not suitable? I don't know. I'm sure there are things where I can't think of one off the top of my head, but I'm sure there are cases. You would just have to handle those with a separate piece of state and not use your normal database. Oh, so this is not. This can be a problem if you have. The problem is. How do you ensure that on the clients will be on the same? The order on the clients will be the same. I guess you can't always. If you can design your application so that order doesn't matter, that's important. That helps. You can have checksums on the data so that you can check that everything came in the right order. If it didn't, go back to the server, do a full refresh. And
let's do one last, and then we're going to be out of time and out of questions as well. Yeah.
So I think Precursor itself is fairly fast. I mean, it's doing a lot of stuff. It's sending, every single mouse move is going to the other browser, and it doesn't feel that sluggish, right? Because I got a lot of data going in here, and it's fairly fast. So if you're on a very low-powered machine, I wouldn't recommend it, but otherwise it works fairly well.
Awesome. Thank you very much, Daniel. Thank you.